Okay, so last time we wrote this script and we had just a few things in the script. So the purpose of this script was to calculate the velocity of a skydiver. We had our velocity equation, and then other things that we had to put into the script were our variables. We had to declare all of our 4 variables that we had in our equation, and we had to put our housekeeping tasks inside of the script. So that's kind of the main parts of the script. In our velocity equation that we have down there on line 16, why do we not need dots in this equation? There's no dots in line 16 in the velocity equation. Because they're all scalar values, right? We all answered at once. So we have no vectors in this problem, so we don't need any dots. What happens if I were to, let's say, change my time variable from a scalar to a vector? So now I want to calculate not just at 12 seconds, but I want to calculate the velocity at a whole bunch of time frames. So I'm going to change my time from 12 to, let's say, a vector with values between 0 and 20, and I don't really care what the increment is. What should I use? Should I use colon operator or should I use linspace here? Doesn't matter. Doesn't matter, right? Which one do we want to use? Linspace? It's the first thing I heard. So linspace, if I want values to be between 0 and 20, what do I have to tell MATLAB here? Yeah, so we could do, if we did 5, that'd be 5 values. By default, linspace gives us 100 values, so I don't specify that third input, I'm going to get 100, right? If I wanted 50, I could put 50 there, right? It's up to you. So now I have t as a vector. Do I need to change anything in my velocity equation? What do we think? How do we go about thinking about that? So where is our vector? We just have the t out there. It's kind of like in that very last term. Abdul?
Yeah, before the multiplying to t, you have to add that dot.
So right here?
Yep.
What do we think about that? Yes or no? Tark?
No.
Tark says no. Why not?
It should be after the square.
After the square? Here?
Yeah.
What do we think about that?
I don't think you need a dot.
We don't think we need dots anywhere. What do we think? Let's vote. So do we need a dot here before the t? Anybody? Are you a fan of that one? A couple people? What about a dot over here, like Tark was saying, between the square root and the tangent? Anybody? Maybe both? Uh-oh. That's too many options. And then Sawyer says no dots. How many people are in the no dot camp? A few more. What do we think? So no dots are actually required because we only have the one vector. So we have a vector, and if we break this down kind of term by term, inside of our hyperbolic tangent, so we have the square root of g times c over m. That's all going to be a scalar value, right? All those g and c and m are all scalars, so the square root of a scalar is also a scalar. A scalar times a vector, no dot required, right? And then so what is going to come out of the tanh function? Is that going to be a vector or a scalar? Vector, because t is a vector, so tanh is going to give us a vector, right? So now we've got square root of that stuff times our vector on the right side. So what's the square root? Is that going to be a vector or a scalar? Scalar, so we have a scalar times a vector. Dot, no dot. No dot, right? So no dots are necessary in this equation, even if we change t to be from a scalar to a vector. Now if I was going to go crazy and I had, I don't know, a bunch of different masses and a bunch of different times, so I had mass was a vector and I had time was a vector, then I would need some dots in there, right? So if I've got more than one vector floating around, usually I need a dot. If I only have one vector, a lot of times I don't need a dot. All right. So when we create scripts in MATLAB, there's a couple things to keep our eye on, scripts or functions. So anytime we create files like this in MATLAB, we need to keep our eye on a couple things. So first off, when I made that change, I made t and I set it equal to a vector with the linspace. You'll see that up here at the top of my editor window, next to the name of the file, MATLAB has put a little asterisk in there. What does that mean? That means that you've changed something in the file and you haven't saved it. So if you go and run this, sometimes MATLAB will be nice and save it for you. Sometimes it won't. It's kind of a mystery. Most of the time it does a pretty good job, but because it tries to be helpful. But if I were to go run this file, it might not have saved that change, and then therefore it might not make the change. So I'm going to run it, and it's still going to give me, 1 velocity value instead of 5 velocity values. So every time we make a change to a script, it's always a good habit to get into to save it, double check and make sure that that asterisk went away before we run it. So how do we run a script in MATLAB? Click the big green run button, right? That's pretty easy. That's going to become your downfall in a couple minutes. So don't rely too much on the big green run button. Green run button is good for scripts. So we can hit the big green run button, and then what happens? So if we go back and kind of split screen our file, and now we can look at our workspace, we have all these variables defined in our workspace. So everything that we defined in our script, we have G and an M and C and T and V. All those variables now exist in our workspace. So that's a nice thing. So scripts can write variables to the workspace, and we have all that stuff hanging out there. What that also means is that scripts can pull variables from the workspace. So if we have stuff sitting in our workspace, we don't necessarily have to define it inside the script. The script can access all of that information. So let me show you an example of that. So if I were to not define G inside of my script, so I'm just going to comment that line out by putting the % sign at the beginning there. That means MATLAB's going to ignore the fact that I've set G equals to 9.8 inside my script. The other thing I have to do is I'm going to get rid of this, comment this housekeeping task out to clear out the variables in my workspace. So now I've gotten rid of the clear, and I've gotten rid of the G declaration in my workspace, but I still have G hanging around over here. I've got G hanging out in the workspace, but I don't have it defined in my script. If I run this script again, MATLAB's still going to be happy. It still knows that G was defined inside the workspace, and it's happy with that. The bad thing about that is that you can have G defined as something in your workspace and forget to define it in your script and mean it to be something else, and then you're lost, right? You haven't set G to be the right value. So I always say it's a really good idea to have your housekeeping task where it clears out your workspace, so then you start from scratch. You don't have any variables hanging around there that could be confusing, and then you always just define every single thing that you need in your script inside the script, so you don't have to worry about it. It's nice that that stuff's accessible from your workspace, but I wouldn't rely on it because sometimes that'll get you in trouble. So make sure when you're doing your scripts, do your housekeeping tasks, clear everything out, start from scratch, and define everything inside of the script. One other thing to talk about regarding all files in MATLAB. So if we go back to kind of this main editor window, you'll see over here on the right, far right of your screen, up at the very top, we have this nice green box. This box here will change from green to yellow to red, kind of like a stoplight. Green means that MATLAB is happy and it thinks that you don't have any errors inside of your script or your function that you're writing. If it's yellow, what does that mean? That usually means that MATLAB's trying to warn you that maybe you're doing something you don't want to do, but it's not completely unhappy. It's not going to cause an error. It's not going to yell at you when you run the script. So when would that come up? So for example, if I didn't suppress the output by putting a semicolon at the end of the line, not only is MATLAB going to highlight the equal sign in yellow and then underline it, it's also going to change this box to be yellow. If you put your cursor over top of it, you'll see it says warnings found. And then if you go down to where the little yellow line is, it'll also show you the same kind of warning statement that says, hey, you might not want to print all this stuff out to the screen. It's just a friendly warning. If you run this script as it is right now, MATLAB is not going to be angry. All it's going to do, so if I save this and I run it, all it's going to do is it's going to, instead of printing out nothing, it's going to print out that G is equal to 9.81 because we didn't suppress that output. So that's a warning that you could get, and warnings are okay. MATLAB's happy with that. Generally, we kind of want to get rid of them we always usually want to check out and make sure that we have this nice green box up here. That's usually a good sign that MATLAB's not going to be angry. So what else could happen? So if I, for example, forgot to define my C variable, so I'm just going to comment it out for right now, but if I forgot to put it in my script at all, what's going to happen? I have this nice green box, no warnings found. I go to run it, and I got the dreaded ding, and I got an error, right? So the green box is not foolproof because I didn't define C inside of my script. MATLAB doesn't know what C is, so when it gets to this equation, it says it hasn't defined C. So the green box is not foolproof. The green box can lie to you, but it's usually a good indication that you have done something right or wrong, and usually you're okay. So let's see. So we're going to put C back into the script. Let me see if I can get it to give you a nice red box that would make MATLAB really angry. Let's try this. Here we go. So I took out the multiplication sign. So a common thing that people will do because they're used to, when you write an equation, when you're writing it down, you don't necessarily have to put a multiplication symbol between a variable and a parentheses. A lot of people will forget to do that in MATLAB. You have to put that multiplication symbol there. If you forget, MATLAB will try to remind you by making the traffic light box red, and it'll say you've probably got some sort of error, and it's going to tell you have some invalid syntax, that you're missing something. It's not always telling you what you're exactly missing, because in this case it's suggesting that we're missing a parentheses or a curly bracket or a square bracket, but what are we really missing? We're missing a multiplication sign. But you can see that box will automatically kind of update and try to be helpful and show you that you've got some errors. So you just kind of want to keep your eye on, when you're getting ready to go run your script or your function, that you at least have the yellow box, if not the green box up there in the top right. If you have the red box, you're always going to get some sort of error, and then you're going to have to troubleshoot. So it's usually a good idea to try to see if you can figure that out before you press the green run button. So any questions about scripts? Okay, so what you can see inside of the script is that we have pretty much made this standalone. We don't have any sort of inputs from anybody who's running the program, and we're not really outputting anything, right? When we run it, we don't really get anything printed out to the screen. We're not asking somebody to enter something in. We're just running it, and then those variables are showing up in the workspace, right? And if we look at the variables, so let me run this one more time. So we look at our variables. We can look at them over here in the workspace. So if we want to look at the velocity v, we can look at it, but we can't see too much here in this window. If I double click on v, MATLAB will open up this kind of spreadsheet looking variable window that will show me all the different values of v that I calculated with my script. But a lot of times that's not super useful. Sometimes we want to actually see what that looks like on the screen, or potentially ask somebody to input what, say, t is. So we want to allow the user to change and give us the current time value that they want to calculate the velocity for. With a script, kind of how it is, there are no easy ways to define inputs and outputs from a script. Everything kind of has to live inside of the script. But we have some other commands in MATLAB that will allow us to do inputting and outputting. So what we're going to do is I'm going to take out t here that we have defined in the script. I'm just going to comment it out for now. And we're going to do what's called interactive input to allow somebody to enter in t. So I'm going to add some things in here to interactively input t. And so when we use interactive input, it's a function in MATLAB, kind of like min or max or mean. It's just another function that MATLAB has. And it has a specific format like most functions. You have to tell MATLAB the name of the variable that you want to save those values in. So you say t, and you say t is going to be equal to something. And the thing that you're going to set it equal to is what's called the input command. So this is easy to remember. If you want to interactively input something, you use the input command. So you type input, and then you open your parentheses. And inside the parentheses, you provide the message that you want to display to the user to tell them what to input. So if I want the time t, I might say inside single quotes, enter the time t. And you might say in seconds so that they know what the units are. You close your single quotes, you close your parentheses, and you can put a semicolon at the end. And what will happen, we go to run this, we're going to get that message, we're going to have to enter in the values for t interactively during the running of the program, and MATLAB will save that into the variable t. So let's go ahead and save our script. We're good with our green box over here on the right, so we can probably hit the green run button. So if we hit the green run button, we're going to get our message, enter the time t in seconds, and now we as the user are required to do something. So you can see that MATLAB over here on the bottom left now has this message that says waiting for input. So it's kind of in this waiting mode. It's waiting for us to do something. So it's waiting for me to enter in something. So I can enter in, so say maybe 10 seconds. I enter in 10, I press enter, and then MATLAB has calculated the velocity at time is equal to 10 seconds. You can also enter in vectors in using the input command. So if I run this another time, I can enter in a vector. So I could open my square brackets. I could say I want to calculate t at 0, 2, and 15 seconds. I just have to put them in square brackets to tell MATLAB that's going to be a vector. I press enter, and now if I look at my v variable, I have the 3 values, the 3 velocities at each of the times that I have. So with the input command, you can enter in anything you want. It's just kind of a nice way to get some input from the user, as opposed to them, they don't have to go into the script and edit the script file. They can give you that information on, on the fly kind of while they're running the script. So that's interactive input. The other thing that you want to learn about, or that we need to learn about with regards to scripts, is what's called displaying things. So our velocity is kind of trapped in the variable. We can see in the workspace, but we're not really getting it printed out to the screen. What if I want to print it out to the screen? I'm going to use something similar to the input function, but it's called display. And so the display function I'm going to display my velocity. You can do a couple different things with the display function. So the display function is DISP, so it's just kind of an abbreviation of the word display. And inside the parentheses, I have a couple different options. I can either put variable names, so I could put V, and it would display the numbers that are in V, or I can display some sort of message to the user, or message to display in the command window. And I do that the same way I did with the input by putting it in single quotes. So I could say, the velocity is, close my single quotes, close my parentheses, and then I could have a separate display function to actually display the values that are in the variable V. There are ways to do both of those things in one display function, both do like a sentence and variables. But honestly, it's just easier to use 2 different display functions. So, so that's what I'm going to teach you guys. So now, if we save this script and we go back and we run it again, we're going to get our interactive input. So we're going to have to input something. So let's say 8 seconds, press enter, and then we get our nice display message that tells us what the velocity is at 8 seconds. So when we're doing scripts, there's no built-in or easy way to do inputs or outputs, so we have to use these extra functions, the input function and the disp or display function, to be able to get inputs and outputs out of a script. Yes, sir?
I mean, do you actually have to do that? Can you just delete the semicolon? I mean, you still need your answer.
Can. It's kind of the lazy way of doing it. And I will say that if I ask you to use a display function, I actually want you to use it, not to do it that way. The bad thing, I mean, there's no real disadvantage to just unsuppressing the output and getting it to print out, except for you don't get any sort of message, like you can't really, so you'd at least need a display function to say the velocity is, and then you could print out the number either way. I just think it looks nicer to have it with the display function, personally. Yeah. So that's kind of what I teach you. Yes, sir?
Can you, so you had two display functions.
Mm-hmm.
One with the comment and one with the actual variable. Can you do display function where they're both combined?
You can, but it's honestly just, it's kind of a pain to do the formatting for that. You have to like merge them together and make them kind of like a vector with text in it, and it's complicated. So this is easier. And personally, I just do it this way because then I don't have to remember what the formatting of the other way is. But if you want to go look it up, the display function help will tell you how to do that. So yeah, it's less things I have to remember off the top of my head, so I tend to use it this way. All right, questions about script files? Okay, so we've written our first MATLAB program. Congratulations. And now from now on, for all your homeworks and everything besides the quiz on Friday, we're mostly going to be writing scripts and the other type of file functions. We're not going to so much be worrying about the diary file and entering things into the command window. So we're kind of moving to a higher level of interacting with MATLAB from now on through the rest of the semester. The nice thing about scripts and functions is you always have them around. They're always saved there. They're easy to pull back up and remember what's going on in them. Okay, so we've learned about script files. The other type of file that you can have in MATLAB is what's called a function. Functions are just slightly different ways of kind of writing another MATLAB program. The biggest benefit of a function is that it has inputs and outputs already kind of built into the function. So you don't have to worry about input and display. You get inputs and outputs with a function automatically. So what we're going to do is we're going to write this same Skydiver velocity program in function form. That way we can kind of compare side by side what they look like. So when we created our new script in MATLAB, how did we do that? May you remember? We went to the new button, right? So you could have just hit the big plus sign. It'll automatically open a script. But if you go to the drop-down window here, you can have the choice of a script or a function. So we created script. That basically just opens up a blank window. If we decide we want to do a function, you'll see in the editor window that we get this kind of, form that we have to fill out related to a function. And that's because functions have this specific format and they have these inputs and outputs already built into them. So you kind of have to follow this format whenever you're writing a function so that MATLAB knows that you've got inputs and outputs that you want to either give to the function or get back from the function. So you have to follow this specific format. It's nice that MATLAB provides you this like template whenever you hit the function because you don't really have to remember what the order of the things are and how the parentheses and the square brackets go. You just have to fill in the blanks. So what do we need to do? We need to fill in three things. So first, we need to fill in the name of the function. So that's what goes here instead of untitled. You're going to put in the name of your function. So I'm just going to call this Skydiver function. And just like scripts, when I name my function, I can't put spaces in the name. I can't start it with a number. It can't have any funky characters in it, so no % signs or $ signs or anything like that. It can have underscores, but that's pretty much one of the only special characters. It also can't have like dots in the middle of a name of a function or a script. So it just has to pretty much be letters in there. And then so that's our name of my function. And then I tell MATLAB two other things. So I tell MATLAB what are called my input arguments. So your input arguments are simply just inputs to a function. You can have 0 or 1 or as many as you want, up to infinity. I don't think there's a limit on the number of inputs that you can have to a function. Like I said, you can't have 0, so if you don't have anything you want to give to the function, you don't really need to specify anything. Usually that's kind of defeats the point of using a function. You might as well use a script if you don't have any sort of inputs. So it doesn't really make sense not to have inputs into a function, but you can do it that way. So when you're writing a function and you've got inputs to that function, all you have to do is you have to just put them here inside of the parentheses after the word function, and you separate the names of the variables by commas. So if we have, two inputs, x and y, we'd put x comma y inside of the parentheses, and MATLAB would know that those are both inputs. So that's one thing we have to specify, and then we also have to specify our output arguments. Which also kind of goes hand in hand. There are outputs from the function. And again, we can have 0 or 1 or up to infinity, as many as we want. Again, they just separated by commas, and they have to go over here on the left in between the square brackets. So if we are thinking about our skydiver velocity equation, what would be potential input arguments to this function? So the variables that we have, so like all the values that we've defined. So we could have time. We could also have our acceleration due to gravity, our drag coefficient, and our mass. Or we could say, I'm going to keep all those constant. I'm going to keep mass and the acceleration due to gravity and the drag coefficient constant. I'm going to define those inside the function and just get t from the user as an input. Either way is fine. So you kind of get that choice whenever you're creating a function. What do you want to allow the user to be able to input? So that's what you want to think about when you're asking yourself, what should I make as an input argument? That's the thing that you're going to want the user to provide to you. So either one. In this case, let's just go ahead and do all 4 variables. So I'm going to delete out the input argument kind of placeholder, and I'm going to replace that with my list of variables. So let's do m, comma g, comma t, comma c. And you can see that MATLAB kind of by default put spaces on either side of those. If you want to keep them there, that's fine. If you want to delete them, so we don't necessarily need the space before our list of variables, it's just kind of up to you what you prefer. And then these all turned yellow because we haven't used them inside of our function yet. We haven't told MATLAB what we're going to do with all those variables, so it's kind of like, maybe you don't really need these at this point. We'll get to, when we write our equation, that will go away. So what outputs do we think we might want from our skydiver function? The velocity, right? And so we only have one thing we're trying to calculate here in this function, so that's pretty easy to think about. But if we had more than one, then we could go ahead and add that to this list. We just have to separate them by commas, just like we did with the input arguments. Again, we don't necessarily need the spaces in here, but we do have to have the square brackets for the output arguments, and you have to have parentheses around the input arguments. So that's required. So again, at the top of a function, just like I did with the script, I always kind of like to put a little header up there. And so the first thing I like to do is remind myself what the function's even doing. So calculates velocity of skydiver. And then I like to define my inputs. So in this case, we have inputs. We have m, which is our mass, and that's in kilograms. We have g, which is our acceleration due to gravity, which is in meters per second squared. We have t, which is our time in seconds. And then finally we have c, which is our drag coefficient, which is in, where are my units on that? Kilograms per meter. And then I also like to remind myself what my outputs are. V, which is my velocity in meters per second. So you don't necessarily have to put that header up there. It's just kind of a nice thing to have. I'm not going to require you to do it. I wouldn't take off points if you didn't have the header up there. It's just kind of an extra thing that would be nice to have when you're writing programs. Just good general programming practice. So now that we put our header in here, what's the next thing that we did in our script? Before we did our equation, what do we have at the top of our script? Housekeeping tasks. So we had housekeeping next. So we put housekeeping tasks in the script, mostly because remember we were writing and reading, we can get variables from the workspace. So it was always a good idea to have those housekeeping tasks so that we could clear out our workspace and we didn't have to worry about variables that were still around. A function operates slightly differently than a script. Functions don't really care about the things that are in the workspace. So they can't write variables. Well, I say the only thing that they're allowed to read or write from the workspace are either the inputs or the outputs that we defined up there at the top. So we have to, so we don't really need to have the housekeeping tasks because once we're inside this function, once MATLAB is in here, it doesn't care what's in the workspace. So we don't really want to put the housekeeping tasks in here. Another reason is that if we put the housekeeping tasks here, we go to run this function, we've already defined M and G and T and C kind of up here in the first line of the function as an input. If we go and clear out our workspace here, what's going to happen? M and G and T and C are going to go away, and they're going to be gone, and then we're going to run into trouble. So we don't want to put housekeeping tasks inside of a function. So no housekeeping tasks in functions because they don't interact, functions don't interact with the workspace. So now what do we need to do? Do we need to define M and G and T and C? Yes, no, maybe?
Yes.
So we will have to, but when we do a function, we do that when we go to run the function. We don't define it inside the function because we're asking basically for that as an input from the user, and so we're going to do that when we run it, kind of like we use the input command, and we were able to provide that on the fly while we were running the function. So we don't need to define any of our variables in here. In fact, it's kind of redundant. So if I were to run the function, provide MATLAB those 4 inputs, and then define them inside of this function, it's really kind of useless because we've given it the same thing twice, the same information twice. So it's not something we need to do inside of a function if we have those variables defined as input arguments. So now what's the only thing then we have to do inside of this function? The equation, right? So all I'm going to do, save myself some time and typing, is I'm going to copy my velocity equation from my script, paste it over inside my function so I don't have to type it out again. So now I need to run my function. What should I check before I run my function?
Maybe you need to save it.
We need to save it, but what else should I check? Catherine? The green box, right, our traffic light. So we've got a green box, so we're pretty confident that MATLAB's happy. We're hopeful that we're not going to get any errors. So we're good with that. So now we need to worry about saving our function. So saving a function is pretty simple. You just hit the save button. MATLAB is going to go ahead and suggest a name for your function that matches the name that we put in that first line of the function in the function header there. I would highly suggest that you don't change that name. That's what MATLAB is looking for when you go to run the function. It's looking for the name of the actual file, and as long as the name of the file matches the name of the function that you put at the top of your function file, MATLAB's happy. So I would highly suggest you just say, thank you for providing me that name. I'm going to hit the save button and not change it. If you happen to change the name of your function, so say I add something in there, and the name that's up there at the top no longer matches the name of the function, MATLAB's going to be angry, and it's going to give you this nice warning, and it's going to say, hey, these don't match. Do you want to fix this or not? And so it's going to try to convince you that they should be the same thing. So it's always just good practice to make sure that those have the same name. So now we've saved our function. So what should we do? We want to run it, right? So what's everybody tempted to do is to hit the magic green run button up there, and this is going to be a disaster. So let's clear out our workspace. So we're going to clear and CLC, clear out the command window so we kind of start fresh. And let's see what happens when we hit the magic green run button. So we hit the magic green run button. Uh-oh. MATLAB says I didn't provide input arguments. So when I hit the magic green run button, I don't have any ability to provide MATLAB the 4 inputs that it's asked me for. You'll see that MATLAB's going to try to be helpful, and it's going to pop up this little box up here next to the green run button, and it's going to say, you know, would you like to define your inputs here? You can do that. However, I will say that that's going to get you in trouble because MATLAB saves that information. So if you ever want to change the mass or whatever it is, it's a little more difficult to do that. So I would highly suggest you don't follow MATLAB's recommendation up there at the top. But we learn how to run the function in the command window, which is, I think, the easiest way to do it. So how do we run a function properly? Instead of hitting the green run button, we take everything on the first line of the function, except for the word function. So we take our output arguments all the way over to our input arguments. We copy that information, and we paste it down in the command window. And now we have a couple options. We can define variables M, G, T, and C, or I can just replace the names of those variables in the parentheses with actual numbers. So, but I just have to make sure that I have them in the right order. So I had M was my mass first, so I put in my mass value. We were going to do 68.1 kilograms. Then the next one is G, so that's my acceleration due to gravity, 9.81. Then I have my T, right? So let's do, I don't know, 10 seconds. And then my my drag coefficient, which is 0.25. As long as I have those separated by commas, and they're in the same order, M, G, T, and C, MATLAB's going to be happy. I press enter, and you'll see that I got my velocity, or my output argument, V is equal to 49.42, printed out to the screen. So that's the proper way to run a function so that you can define what the inputs are and what the outputs are from the function. So questions about functions. How do we do? Yes, sir.
Can you still do the input and display?
Great question. So you can. There is nothing wrong in MATLAB's eyes with using the input and the display function inside of a function. However, those are MATLAB's rules. Dr. Kinney has her own rules, and Dr. Kinney's rules are that you cannot use the input and the display function inside of a function because they're basically doing the same thing as input arguments and output arguments. So it's like doing the same thing twice. So I have a rule that you cannot use the input and the display function inside of a function. You can use them in a script, you use them all you want in the scripts, but they do not ever belong in a function. And I'll say this probably 15 times by the end of the semester, you know, don't do it. I will take points off for doing that because it just is like it's like my pet peeve. It's the thing that drives me nuts when people put those into functions, and so I will take points off for that. So that's your fair warning. So input and display commands go in scripts, never, ever, ever in functions. Okay? Do you have a question?
Yeah. Like some numbers are constant, like just the time is changing.
Mm-hmm.
So can I describe those numbers as fixed numbers in the function?
Yeah, so if I wanted to, you know, just have T as an input to my function, I could do that. So you could just take out the other three, M, G, and C, define them inside of the function, you know, down here, just like we did in the script. So you have that option too. It's kind of up to you. You know, when you're creating your function, you get to decide what are going to be the inputs and the outputs, unless I say use these. Sawyer, do you have a question?
Yeah, can I write the velocity is up there in between the brackets and then put a comma?
Oh, here?
So it types that out like it did in the other?
No. So that's one of the disadvantages of a function is that you don't get like nice looking output.
Yeah.
So you kind of are stuck with this format.
All right.
So that's another difference between a script and a function. So other questions about that? All right, so now that we've learned scripts and we've learned functions, let's kind of come up with a list. Let me put these side by side. This is another nice thing you can do in your in your editor window in MATLAB is you can drag around these different files, put them side by side or one on top of the other, however you want to do that. And then you can kind of look at them side by side and make some comparisons. So if we're going to list out some differences between scripts and functions, what might they be? So let's see. I'm going to erase this over here. What's one difference between a script and a function that we can see?
Housekeeping.
Housekeeping. So which one has housekeeping? The script, right? So we have housekeeping here. No housekeeping. In a function. Why? I could see that, right? That was an easy thing that's different. Why do I get housekeeping over here and not over there?
Because it could clear out your function.
So in a function, if I put the housekeeping task up there at the top, right here, line like 9 or so, what could happen is it's going to clear out my input arguments. So those are going to disappear and they're not going to be defined. So that's annoying. What's the other? Why do I need to have them over in the script?
You have a defined like variable.
Right. So with the script, we can interact with variables in the workspace. So interacts. So scripts can interact with variables in the workspace. If we have something defined in our workspace, I don't necessarily have to define it inside the script file. So I'd really rather just make sure that I have everything nice and contained inside my script file and clear out all the stuff that's in my workspace. I don't have to worry about it. That's not the case for function files. So function files can kind of interact with the workspace, but only the input arguments and the output arguments are in the workspace. So if I created any sort of intermediate variables inside of my workspace, so like on your homework that you were doing, you had to calculate k, and then you had to calculate the u's, right? So if I created k inside of my function, and it wasn't an output for my function, it would just live inside of there, and the workspace would never see it. It would kind of go away once I was done running the function. So intermediate variables, anything but your input arguments and your output arguments don't exist in terms of the workspace variables. What are some other differences between scripts and functions? We just talked about a really important one regarding input and output.
Display function.
The display function and the input function, right? Those are only, according to Dr. Kinney's rules, only allowed in which files? Scripts, right? So, input and display functions, I'm going to say are appropriate rather than allowed, because they're allowed in both technically, but appropriate to use in a script file, not in a function file. Anything else? I think that's all I had. So those are kind of main basic things, big differences between scripts and functions. All right, so on Friday we have our quiz. I have off hours on Friday, sometime in the afternoon. I can't remember. Feel free to come by if you have questions, anything that's bothering you before the quiz, or send me an email, whatever you want. And then Monday, what we're going to do is we're going to do another in-class exercise, learning, talking about scripts and functions, so you guys get some practice writing your own. All right? So we'll see you on Friday.